Okay guys, today our goal is our objective is we want to be able to construct and interpret a confidence interval for the means when sigma is unknown. All right, so example 5 is going to say for their second semester project in AP Statistics, Ann and Tori wanted to estimate the average weight of an Oreo cookie to determine if the average weight was less than advertised. They selected a random sample of 36 cookies and found the weight of each cookie in grams. The mean weight was X bar equals 11.3921 grams with a standard deviation of 0.0817. Okay, so what we want to do is now that, like the first lesson we did for section 8.3, we went through the conditions, we went through how to find T star. Now we're going to put it all together with panic. All right, so again, when it says construct and interpret a 95% confidence interval for the mean weight of an Oreo cookie, that's also saying that you need to check your conditions in order to be able to do that. All right, you need to go through the 5 steps of panic. So I've got up here that the first thing I'm going to do is check if my sample size is 36, that means my degrees of freedom are 35. But remember, when you're looking on the blue chart, sorry, I just got to grab it. All right, when you're looking on the blue chart here, there is no 35. All right, so when there is no 35, you go with the smaller number. So we're going to use 30 for our T star, okay, and 95% confidence, and we're going to pair up with 2.042. All right, so what I want you guys to do is, as we go through panic, P, the P stands for parameter. So we need to state our parameter of interest. Our parameter of interest is we want to let mu, remember you have to use the symbol, right, the proper population symbol. We want to let mu equal the true mean weight of Oreo cookies. All right, our assumptions, A in panic, are our conditions that we need to check. So we need to check if it's random, all right, which we've got, they selected a random sample of 36 cookies. All right, so the cookies are randomly selected. We need to check, is our population at least 10 times our sample size? Yes, all Oreos should be at least 360. And then for large counts, in this case, since n is greater than 30, it's fine to use T-star procedures right away. Remember, if n was less than 30, that's when you need to check your dot plot or your histogram to make sure there's no strong skewness or outliers. But even though this passes, you have to write it down to signal that you know that we're okay to use it. All right, so even though we're okay, we don't need to actually check anything or do any calculations or graphing, you still need to state that you know it's okay. All right, our name for this is a one sample T interval for the mean. It matters that you use the letter T. It matters that you say for the mean, right? In section 8.2, it was always for proportions. Now it's for the mean. All right, so then we've got our formula, X bar plus or minus T star times S over root N. When you plug everything in, please make sure that you're practicing typing this in your calculator, right? Then both the minus and the plus. The minus gives you the left answer. The plus gives you the right answer. Okay, this is a pretty narrow interval, but it should make sense, right? Think about Oreos. I love Oreos. If you think about Oreos, they're all the same size. So the weight of them shouldn't fluctuate, right? It's logical that our standard deviation up here of 0.08 grams is really tiny because Oreos are pretty identical to each other. So the weights aren't supposed to fluctuate, all right? They're not supposed to vary a lot. So how would you interpret this in the context of the problem, right? Conclusion in the context of the problem, C squared. So we're going to use the same idea that we've been using. We're just changing from talking about proportions to talking about averages. So I am 95% confident that the true mean weight of an Oreo cookie is between 11.3643 and 11.4199 grams. Okay, now on the packaging, question B, the stated serving size is 3 cookies, 34 grams. Does the interval in part A provide convincing evidence that the average weight of an Oreo cookie is less than advertised? Right? Is Oreo cheating us and not giving us enough Oreos, right? Enough volume of it, the weight of an Oreo. Well, let's break it down. If they give us 3 cookies as 34 grams, then I first started with saying the stated serving is 34 grams is for 3 cookies, which means if I divide the 34 by 3, I'm going to get 11.33 grams for each cookie. So if the stated serving size is 11.33 grams per cookie, and we found that the average weight of cookies is 11.36 to 11.42, right, roughly, grams, then that means that our estimated weight is higher than what they're advertising. So does that mean that the average weight of a cookie is less than advertised? No. All right. This time it's a good thing to be above average, right? We get more Oreo. Yay. So because all values in the interval are greater than 11.33 gram, then there is no evidence that the average weight is less than advertised. In fact, we could probably do some more data collection to see if it's actually more than advertised and we're getting extra Oreo, which is great for us. But as a company, that's not what they want, right? They want to be cranking out exactly what they say they're cranking out. If they're giving out a little bit extra on every single Oreo, that's going to wind up costing them a ton of money. Even though it's it's such a tiny decimal difference, right? But if you think about the millions and millions and millions of Oreos that are produced, every little bit adds up, right? And then that's going to lead to them losing money. Okay, next problem. As part of their final project, right? We will definitely be doing final projects like these. So either like the Oreos, and you guys will see we're going to be doing a couple things this spring because now we're going to be gaining enough knowledge that we can bring it all together. All right. So as part of their final project in AP Statistics, Patrick and Tommy randomly selected 18 rolls of generic toilet paper to measure how well this brand could absorb water. To do this, they poured 1/4 cup of water onto a hard surface and counted how many squares it took to completely absorb the water. So here are their results. All right. Now, I guess I put this silly because I wanted you to do this problem on your own, but now you can see this. So, where did I get these from? I hope you know. Okay, I hope you know that we did all the data in a list. We did one variable statistics to get my mean. We use the sample standard deviation because this is not a population, so you are not using the sigma x in your calculator. You are using the SX that they give you. Sample size 18, means degrees of freedom 17. I hit my blue chart, and I got this as my T star. So what I want you guys to do is I want you to try panic, okay? Do the whole problem and see where you wind up, okay? So pause the video, do the whole problem, okay? And then check your work. I have the parameter is let mu equal the true mean number of squares needed to absorb a 1/4 cup of water. All right, it was randomly collected. We're safe to assume the number of rolls, not brands, the number of rolls of toilet paper for this brand is definitely greater than 180. Hopefully you have all this, because this is an important part of this problem, right? Since n was less than 30, when we do our large counts, we need to look at the dot plot. You need to draw the dot plot. Okay, so having it in your calculator is not sufficient. Okay, you can't be like, I graphed it in my calculator and it's fine. You need a sketch. Okay, we're not looking for a Picasso or a Van Gogh, but we need a sketch. Then you need to say there's no strong skewness or outliers, which means it's okay to use our T-star procedures. Okay, it's a one sample T interval for the mean. Here is my interval using the one variable statistics I got up here. And then my conclusion, we are 99% confident that the true average number of toilet paper squares needed to absorb 1/4 cup water is between 22.99 and 26.89 squares. And guys, I know this is more writing than you've ever done in math. However, this is required. So there is no option to shortcut this stuff, okay? This is a full credit problem. All right, this is a full credit problem. All of these pieces. So if you don't have all of this, then you won't be earning full credit, okay? If you just find the interval, that's it, right? You just do the interval, maybe you'll get 1 out of 8 points, maybe, because that's not the important part. I mean, it's the important part of the problem, but all of this together is the entire problem, all right? Now, last problem. A counselor wants to estimate the average number of text messages sent by students at his school during school hours. He wants to estimate mu at the 99% confidence level with a margin of error of at most 2 texts. A pilot study indicated that the number of texts sent during school hours has a standard deviation of about 9 text messages. How many students do we need to survey in order to estimate the mean number of texts with 99% confidence? So let's break this down. What part of our formula, right, gives us the margin of error? Well, it's the second part. So like here, it's point estimate plus or minus margin of error. So here's our margin of error. But if you think about it, in order to know your t-star, you have to know your sample size. And in this problem, we don't know our sample size. That's what we're trying to find out. So if you don't know n, you can't find t-star, which means for these problems, you need to go back to the z-star because it's the only way we can do it. All right, we have to go back to the z-star, which means our margin of error, right, is going to be equal to z-star times sigma over root n. Now, this problem is saying a margin of error of at most 2 texts, which means 2 is going to be the biggest number we can get. 99% confidence means our z-star is 2.576. Our standard deviation was 9, and we want the square root of n. All right, so we're going to do a bit of algebra, right? Divide by this. You can either cross multiply with your proportions or however you're going to approach it, right? And then we're going to wind up with 134.4 is like n has to be greater than 134.4, which means that we need at least 135 students. If you need to poll a decimal of a student, that means you need to poll the entire student. So this would be our answer. Our sample size would need to be at least 135. Good job today. We'll talk later.